Section 7.4, Properties and Applications of Logarithms. 7.4, Objectives. First, the student will know and apply the properties of logarithms. The student will be able to use the change of base formula and solve some application of logarithms. Our properties of logarithms. We'll start by letting a, the logarithmic base, be a positive real number but not equal to 1. X and y will be positive real numbers, and r can be any real number. Then our first property says if we have the log base a of the product x times y, we can separate that into the log base a of x plus the log base a of y. And we call this the product rule. Okay. The product is in the argument in the single logarithmic expression, and you can separate that into the sum of the logarithms of the factors. The second property is what we call the quotient rule, and it's the log base a of x divided by y will be the log base a of x, which is the numerator, minus log base a of y. Again, this is the quotient rule. The last one is called the power rule. You do not need to know the names. This is the one we will use most when we're solving log equations, and that says if you have the log base a of some number raised to a power, the argument is an exponential, then you can take that power down in front of the logarithm as a multiplier. Okay, that's how we're going to get our variable out of the exponent. So again, we have these three properties. They are on your formula sheet that you are allowed to use for the test, but we need to know how to apply them. In our examples, we're going to work on those applications or working through them. So in my first example, I have the natural log of 8 times x to the 5th divided by y to the 3rd. Our argument of our logarithmic expression has three terms: the 8, the x to the 5th power, and the y to the 3rd. So when we expand this, which is what we're trying to do here, we're going to have three logarithmic expressions. We're going to have the natural log of the 8 plus the natural log of the x to the 5th minus the natural log of the y to the 3rd. Okay, because the 8 and the 5 are in the numerator, or the 8 and the x to the 5th are in the numerator, they're being multiplied with the product rules. We're going to add those two. And the y to the 3rd is in the denominator, so we're going to subtract that one. Okay, now we can simplify the second two logarithms because they both have powers. We bring those powers down in front, and one more rewrite. We'll have the natural log of 8 plus 5 times the natural log of x minus 3 times the natural log of y. And this is our expanded expression. Okay. Normally we don't expand it all out like that. Normally we will go in reverse. We'll have an expanded section. We'll want to work it into a single logarithmic expression. But in our first examples, we're going to expand it. Example 2, Again, we're going to expand the expression as much as possible, simplifying any numerical expressions that can be evaluated without a calculator. So we have log base 6 of a product 216 times x to the 8th. So we're going to go ahead and we'll expand this into a log base 6 of the 216 plus a log base 6 of the x to the 8th. Okay, now we can take this a step further. The first one here, this can be reduced. Alright, so if we came down here and said log base 6 of 216 is equal to what? We would change this to an exponential by taking the base, go across the equal sign to get the power, and that has to equal the 216. And we know, if you don't know, you can do it trial and error. Ran out of room. 6 to the x is equal to 6 to the third. 216 is 6 to the third power, which means x is equal to 3. Okay, so x is equal to 3, so this expression is equal to 3. So we can come up here and we can say 3 plus 8 times the log base 6 of x. And on that second logarithmic expression, I used the power rule and brought the exponent down in front as a multiplier. Okay. On the previous problem, I was not able to evaluate the natural log of 8 because my base is e, which is an irrational number, and 8 is not a power of e. So we couldn't evaluate this, so we'll just leave that as a natural log of 8. On this one, we could simplify, so we did. All right. Use the properties of logarithms to condense this expression as much as possible. Write your answer as a single log term with a coefficient of 1, and all exponents should be positive. Okay, these are all log base 10s, which is good. We want all the logarithms to be the same. My first step is I'm going to take the coefficients on the logarithms, the 3, the 7, and the 5, and bring them back up as exponents. That's the power rule in reverse. So I'll have log of x to the 4th y squared to the 3rd plus log of 1 over x to the 7th minus log of y to the 5th. Okay. Now the next thing that we're going to do is we're going to just use our exponent rules and simplify these arguments. So I will have the log of x to the 12th y to the 6th plus the log of 1 over x to the 7th minus the log of y to the 5th. Okay. So again, I took power to a power. You multiply the powers. Here, 1 to the 7th is 1, x to the 7th, and then, of course, y to the 5th. Now I am going to combine this into a single logarithmic expression using a combination of the power rules and the product rules and the quotient rules. So this can equal 1 big log base 10 of a fraction, and I have an x to the 12th, a y to the 6th, and x to the negative 7, and then on the bottom a y to the 5th. Okay, where did the negative 7 come from? Since my x is in the denominator here, to move it to the numerator, I have to switch it to a negative number. Okay, so when I brought it to the numerator, it goes up here. I could have put it in the denominator, but it's easier to think of this way. Now when I simplify in here, one last time, I'll have a log, and I have, add your exponents, I'll have x to the 5th, 12 plus negative 7 is 5, and the y's, the 5 y's on the bottom cancel with 5 out of the 6 on the top, leaving 1 y, and that's our final simplification for this problem. Who would have thought that this would simplify into a logarithm of x to the 5th times y by looking at it? Okay. And our last one with these properties, this is similar to what we'll be doing in section 7.5 when we are solving logarithmic equations. We have here log base 8 of x squared plus 12x plus 35 minus log base 8 of x plus 5. We want to make it a single logarithmic expression. So what I'm going to do is I'm going to go log base 8 of the fraction x squared plus 12x plus 35 over x plus 5. We did the quotient rule in reverse since this was a minus. This is the numerator, and the one that's being subtracted goes on the bottom. Okay. Now we are going to work on simplifying this. This will still be log base 8. And that top will factor into x plus 7 times x plus 5. And that's still over my x plus 5. And now the x plus 5's cancel, which leaves us log base 8 of x plus 7. Our final answer. These are more the type of problems that we're going to be working with throughout this remainder of this chapter.